Hello everyone, welcome back to our channel. Today we are going to discuss about very important question for board exam. That is to show pendulum motion is the simple harmonic motion and derive the expression for the time period. So it is then combination question is what is the seconds pendulum. So whole answer carries the 8 marks and it's very important for final exams. In this question, what is the question? Show that the motion of simple pendulum is simple harmonic motion. Then we should derive the expression for time period. Then we can define the what is seconds pendulum. First of all, what is the simple pendulum? We are taking one thread. Once you are giving to the one end, we are giving to the rigid support. Another end we are giving to the massive body. Bob also we are calling in our lab. That mass is M. Then we are applying the force on this. Just we are pulling one side and leave it. Then it is making oscillations. Then slowly what happens? That amplitude is decreasing. That is another thing. It will make an angle theta with vertical. And here weight is resolved into two components. One is mg cos theta is balanced by the tension. And one more is mg sin theta is balanced by the restoring force. Mg sin theta is balanced by the restoring force. But what is the use of simple pendulum? With the help of this, we can find out the acceleration due to gravity at given place. Why we are saying that is the given place? Place to place, the value of g is changing. Suppose we are on the surface of the earth. That g value is approximately we are taking 9.81 meter per second square. We are climbing the mountains and we are going inside the mines. In all cases, we can observe that g value is changing. Not only this one, when we are going from planet to planet also, g value is changing. So this is the use of this instrument. It is one of the important experiment in our lab also. Then come back to our question. From this figure, we can write it. Tension is balanced by mg cos theta. Restoring force F equals to minus mg sin theta. From the Newton's second law, instead of F we are writing mass into acceleration equals to mg sin theta. Here mm cancel. A equals to minus g theta. But here you should remember one point. If theta is very small, instead of sin theta we are taking the theta. So sin theta is theta because theta is very small, and from the figure theta equals to x by L. It is making like when you can construct circle also. This is the angular displacement is this x by L. Theta equals to x by L. Then A equals to minus g into x by L. It should be right. A equals to minus g by L into x. Here at that place g is constant, length of the pendulum is constant. So A is directly proportional to minus x, means it shows simple harmonic motion. Our first case is completed. So the motion of the simple pendulum is simple harmonic because A equals to minus g by L into x, then A is directly proportional to minus x. Then second thing, we should derive the expression for the time period. We know that in SHM, in simple harmonic motion, what is acceleration formula? A equals to minus omega square x. Compare equation 1 and 2. From this omega square equals to g by L. Then omega equals to under root g by L. When you know the omega, easily we can find out the time period. T equals to 2 pi by omega. So instead of omega we are writing under root g by L. Then our final expression for time period is T equals to 2 pi into under root L by G. Second part is over. Then third one is what is the seconds pendulum. The pendulum whose time period is 2 seconds. That is called the seconds pendulum, means at the time period value is 2. What is time period? The time taken for one oscillation is called the time period. So the time period of this pendulum is 2 seconds. Immediately we are calling that is called the seconds pendulum. Thank you.